Thanks for coming despite all the grant proposal deadlines and busy semester stuff. I appreciate it. As Guillermo says, I'm directing a relatively new AI research center in Denmark, and we're organizing ourselves around a number of moonshots that capture a bunch of challenges in different sub-areas of AI as they impact different areas of society. And one of those moonshots has to do with preventing the spread of misinformation online, particularly in social media. And the way that we're approaching this is with something called narrative analysis. And it's a human-in-the-loop approach, and it draws on lots of different parts of machine learning, but also involves a lot of neighboring disciplines ranging from history and data-driven journalism and sociology and so forth. We're in the early stages. We're just a couple papers into this initiative. The lifetime of the Pioneer Center is about 10 to 13 years. So we're shooting for something big, something a little bit weird. So I think this is a very different topic that you might be used to. But we think that there's some urgency to this, particularly with the recent advances in generative AI. There's the potential for a massive amplification of misinformation that's becoming harder and harder to detect. And when you hear about preventing the spread of misinformation, the first thing you think of might be fact-checking. And it turns out we're not working on fact-checking at all. Fact-checking, of course, is important. But I'm coming here from the US, and I can tell you firsthand that facts don't change anybody's mind. So that's something that we've learned from the last 6 years or so. And it's very important to balance things out with what we're calling narrative or trope-based reasoning. So we have great respect for fact-checking literature. We're coordinating with other co-PIs that are focusing on fact-checking, but this work is something complementary to that. And if we succeed, the kinds of things we'll be able to do would be detecting bot and sock puppet activity, shill campaigns, misinformation campaigns, and generally to be able to predict narratives in novel settings. Now, when I talk about narratives, depending on where you come from in this audience, the term can have different meanings. So in literature, a narrative involves a protagonist and a journey and transformation and catharsis and so on. And I would say that's the proper definition of narrative, but that's not the kind of narrative I'm talking about. I'm talking about the vulgar sense of the word narrative, which is the one that appears a lot on social media. And it's often in the form of accusations. Sometimes people don't realize that they have a narrative and they start posting some things, and somebody goes on to Twitter or X and says, you didn't say that because it doesn't fit your narrative, right? So there's an implication that there's a narrative. There's a war to control narratives online. So what we're talking about is really, what I'm getting at here are unfalsifiable claims. So it's essentially what gets rejected from fact-checking systems. Most fact-checking systems parse the input and look for check-worthiness. So you could get a check-worthiness score from 0 to 1. Perhaps the thing that's posted says the Earth is flat. So you can parse that and you can say, well, that's a very high check-worthiness score, and then you can go to some structured knowledge repository and do fact-checking. Well, what we want to do is something sensible with all the stuff that gets rejected by that stage. So there's a whole bunch of stuff on social media that is asserted, but is not falsifiable. Now, what's tricky is about the way these things interact. So there are a lot of sort of philosopher king type people on social media that will post things that on the surface are check-worthy. So here you have a tweet that talks about plastic emissions, so waste recycling. And it does appear to be check-worthy. So you can look at this and probably refer to some structured knowledge base. But Paul, why are you posting this? Is it to send us on a wild goose chase and check if these numbers are correct? No. What's going on is that there exist narratives that are lurking behind that tweet. So it's the part that is not said out loud. And I'm just speculating here, but the possible narratives that are advanced by that tweet are things like this business of banning plastic straws is just theater. Or in particular, it's hiding the real offenders in this area, which could be, he's picking on Philippines, but something like banning plastic straws is just performative. So that's one narrative, but you can also imagine narratives that are in opposition to this. And those might say, it may be theater, but it's okay to do this because it keeps people aware of what's going on, or that there was something incomplete in the original tweet, which is saying that perhaps that plastic waste that appears to come from the Philippines was actually exported there from the US first. So there's some kind of latent battle going on that involves narratives, but on the surface it appeared to be facts. And it's important that we approach this in a multicultural and multi-language manner. Because if you aren't in a particular cultural context, a lot of these things don't make sense. It's not clear what the narratives are. So you might have a meme that's posted like the one on the left, and if you were in the US maybe 4 years ago, you would know what all these things are. BLM is Black Lives Matter, KKK, Ku Klux Klan. The imagery is showing some kind of multi-ethnic handshake, portraying unity. But what's interesting here is, in terms of parsing it directly, it does not make any racist statements. So there's nothing in there where it's actually saying that Black Lives Matter is equivalent to the KKK, or that Black Lives Matter is a hate group. But somehow there are narratives that lurk behind that. I'm not saying that they're the same, but it's somehow in a suitable embedding space. You could imagine that there are narratives that are very close to this that might actually come right out and say that Black Lives Matter is equivalent to a hate group. Or the one on the right, I don't know if any of you read Danish, but this was something that happened shortly after I moved to Denmark, and I didn't realize what a big deal soccer is in Denmark and Europe in general. And the Euro Cup was happening, and Denmark did very well on a particular game. And when it happened, Danes just poured out into the streets, and they stopped traffic. The trains weren't running. It was complete pandemonium. And so somebody made a post when that happened and basically said, if you'd had the same conditions, but you were to replace the religion of the people doing it, or if they were wearing headscarves, they had a different skin tone, the reaction of the press would be different. So they're trying to say, when this particular event happened, the press responded with jubilation, and it was kind of exciting and quirky that the traffic stopped. But you wouldn't get the same kind of response if it were different ethnicities. So I had just moved to Denmark. I didn't understand what some of these narratives were behind here, right? Having moved from Jersey City, the last place I lived, it's a different set of narratives, and it's important for us to have both kinds of understanding. So as Guillermo said, I come from a computer vision background, and I like to think in terms of these multimodal interactions. How do the visual signals interact with the text signals? So take an example like a celebrity divorce. So when celebrities like Bill and Melinda Gates get divorced, the core story, there's a set of facts about what happens, and pretty much every news agency has to run some kind of story. So there really isn't that much variation they can come up with the headlines and the leads and so forth. However, in this day and age with social media, each of the newspapers and TV stations need to share something on social media, and it has a thumbnail image. And somebody is picking the thumbnail image to run. And it might be a professional photo editor, or it could be a college intern that's just doing their social media for them. But there's a pool of photos they have to choose from. And these are just 5 examples. And if I look at these photos, and keep in mind, the narratives around Bill Gates have changed since then. But at the time of the divorce, it appears to me that the photos that were chosen are very positive. in their depiction. I would get the narrative here that even though they got divorced, they're going to be fine. They're grown-ups, they're adults, it'll be okay. You look at the proxemics and the pictures, the smiles and so on. But this is not always the case with celebrity divorces. And the news agencies themselves may not realize when they're choosing these thumbnail images to run that it actually is transmitting a certain narrative, right? So another example would be, this is a case of out of context photos that are advancing narratives. So here, this is on the East Coast in the US, and there's a politician that was opposed to the presidential administration at the time. And she wanted to make a point about how that, the politician she opposed was causing the shelves to be empty at the grocery stores. So here's this powerful imagery that's like, look at this grocery store, everything's gone. But remember what I said, this is the US. And if you look closely, what do you notice about the prices? These are pounds sterling, right? So once this was posted, you could imagine at least the gut reaction when you're seeing it is that these narratives are sort of flashing that set of political initiatives was causing, you know, US grocery shelves to be bare. And then somebody calls her out on this and says, that's actually from the UK. And then she just deleted the tweet. So basically that's an out of context. It's not even a deep fake or anything. It's just an out of context photo. But it was very helpful for advancing a particular narrative until it was taken down. Now, the initial steps that we've taken into trying to understand narratives are covered in this paper. This is a collaboration between Cornell and the Pioneer Centre for AI. And I'm just presenting these initial results, and it's a kind of metric learning approach that's based on triplet data. And even though I've talked about some motivating examples with narratives that are kind of heavy and political and so on, for purposes of morale with students and postdocs, I didn't want to get so heavy. I wanted to pick a topic where people would have plenty of opinions and there would be a lot of narratives, but not something so depressing or difficult. Or so I thought, but I tried to pick something as neutral as possible. So the story is, you were in a public restroom and you just washed your hands, and now it's time to dry your hands, and you're presented with these two options. So you've got paper towels or an air dryer, and which one are you gonna pick? And now I look at this and it's so obvious which one is superior. Right, I'm not going to say which one. That's not this talk is not about right or wrong. This is about making sense of different people's opinions. But come on, I mean, you know which one you would go for. It's so clear. But there are lots of opinions here. And particularly during the pandemic, there were a lot of strong opinions about which one was better or worse in terms of spreading disease, or there are all kinds of narratives that emerged here. Now, like I said, I meant to pick something that was kind of anodyne. It turns out it's not, because there is a lot of money to be had in the contracts that the big paper and the big hot air companies would get. If chain restaurants choose one or the other method, those are big contracts. So as a result, it turns out on social media, there are bots and there are misinformation campaigns and smearing campaigns. We didn't know it. I think probably the lesson there is nothing, at least in the US, that is immune to polarization. So whatever topic it is, there's gonna be some kind of polarization, but fine. I think it is still quite an interesting domain to study. And just to jump to what, when I talk about structuring narratives, I just want to jump ahead to look at an example of a visualization. So when we crawled social media like Twitter and Reddit and Facebook comments, basically sources of public comments that talked about hand drying, we had something like 1 million raw artifacts. But you don't have 1 million viewpoints about these things. And looking at a really shallow hierarchy in terms of how these things cluster according to a certain distance metric, which I'll talk about later, you get basically these 4 groups. So one of them says paper towels are better than air dryers. Then you've got air dryers are better than paper towels. You have irrelevant, so things that talked about these named entities but weren't taking a position on them or casting aspersions at either one. And then you've got other narratives that appeared in the discussions. And we were surprised by these because, for example, it turns out a fair number of people dry their hands on their hair or dry their hands on their pants, or they're just some kind of other thing that's interesting but didn't fit into one of those other narrative categories. And you can see when you go down one level of the hierarchy, there are basically people's reasons for why one is better than the other. Now keep in mind, the vast majority of the people responding are not epidemiologists, they're not public health experts, they're not microbiologists, but that doesn't stop people from having opinions. So like I said, ultimately what we want is something that complements fact-checking pipelines. Because as a human being, we think in terms of stories and narratives, and those are the things that we find compelling, and at some point we have to figure out how to put these things together. Again, getting to the visual side of things, particularly younger users of social media use memes a lot to communicate. And that means that narratives can be advanced through memes or memetic templates. So the one on the left has a very classic meme in it. It's, does anyone know what that hat is called? It's called Scumbag Steve. It's a very old meme. But the essence of the Scumbag Steve, it's a kind of templatic meme that's saying, I wish I could help, but I can't because I'm totally lazy. And so wet hands, wish I could help. So this one is basically saying these hand dryers are bad because the motion sensors don't work a lot. Or the one in the middle, this one was just fabricated. It's implying that hand dryers are ineffective. And then this one is just, it's humorous. It doesn't really, it's not clear that it's pushing one way or the other on these options. Now, as I hinted at the beginning, that this isn't just a one conference paper kind of thing. This is a moonshot. We're trying to figure out how to understand these unverifiable claims, the bullshit, gut feelings, like all these things that are on this other side of the wall from the fact-checkable stuff that circulates on the web. So to do that, it's not just going to be algorithms, machine learning, computer science. It's tapping into a ton of different areas. And we're interacting with people at newspapers and TV stations and trying to understand framing and street epistemology and things like that. Again, we're just scratching the surface. This is the beginning of a long project, but it's going to be a lot of papers, a lot of PhD theses trying to understand this. And along the way, we hope to create some data sets and some meaningful ways to measure progress in this narrative domain. In terms of related work, one example of something fairly close is the Social Chemistry 101 project from University of Washington. So a lot of these types of projects started to emerge when transformer architectures became more and more powerful. And as you probably know, that architecture first emerged for text, and then it made its way into vision and other modalities. So in the case of Social Chemistry 101, it's about social and moral norms. And the kind of thing they're looking at is what's considered socially acceptable. So for example, you could ask, if you have roommates, is it acceptable to run a blender at 5 in the morning? And again, it's probably something where there's no absolute right or wrong, but they wanted to know that you could ask the system a question like that and know that it's not in the training set and actually get a decent answer with some kind of explanation. So that project was started a few years ago. It's still going on. And obviously that's something that, as I mentioned before with the example from Denmark, the example from New York City, these are going to be culturally, contextually dependent. You won't just have one set of these rules for everywhere. I mentioned before also that this is a human-in-the-loop project. So human-in-the-loop methods can appear in mundane ways, like just getting your training data labeled, but human-in-the-loop methods can also appear during inference time or everywhere in between. So, and when it comes to things like narratives, we have to come up with some clever ways of getting people to label things, trying to make it fun if possible, which is an art in itself. But some of you probably know about, most of you know about Duolingo, but the founder of Duolingo had a lot of cool projects from his PhD, like ESP Game, Peekaboom, a few other projects like that. And they give us inspiration in terms of how you can get crowds of human workers to label stuff that can give us insights about narratives. We also did a project when I was at Cornell with the Instagram team to try to understand the motivation behind sharing on Instagram. And you might have heard of terms like humble bragging or just straight up bragging, or things like, there are these hashtags like what's your excuse? So fitness people that, you know, they're, say during the pandemic, people are putting on weight, and then there are fitness influencers who get right back into shape and they say, what's your excuse, whatever. There are all these things that are motivating people to post stuff online. And so we approached this with this, this system that we called intentonomy. And you can see the same type of hierarchy that's taking shape here. And there may be what you want to convey by making a particular post, like you finish a hike and you take a picture at the top of a mountain. There's also the question of what is perceived by the viewer when they're scrolling through social media and they see your post. So there are a lot of things, there are people that can brag about themselves. They could brag about their children. They can show off their health, or they can be digging for compliments. So it's another kind of thing, you know, collaborating with Instagram was really nice because they had access to billions of examples like this. And so we were trying to understand this connection between the content in the image and the intent that the user may have. And that's an extremely hard problem. Now let's get to, I've been implying that there's some metric learning that's happening. And in order to do metric learning, you need training data. You need things that are labeled at least weekly in order to understand what entities should be close and which ones should be far away. And then you try to learn a metric. And the technique that we're drawing upon is something that was originally developed in the domain of bird recognition. And it's a technique called SNAC. And I'm gonna describe briefly how this works. And we initially applied it to birds, and then a whole bunch of biodiversity categories. We also applied it to pictures of food. So looking at food, for example, the way that this kind of triplet-based annotation works is that the viewer is presented with stimuli in sets of triplets, A, B, and C. And they are asked, is B closer to A than C is to A? So all of these triplet-based questions have that same form. Is A closer to B or closer to C? But the specifics of the question matter. So in this case, it's visual. When we're talking about narratives, it's in terms of interpreting a textual statement. Specifically, the thing that people were asked in this case was, look at the picture of the food, imagine what it tastes like. So if you're a machine learning person, you might think of that as a latent representation or some kind of embedding in food or flavor space. So look at the food, think about what it tastes like, all of them, and then return which one, B or C, would be most similar to A in terms of that representation. Okay. So now, just working with triplets is going to lead to qubit complexity, and if you're using even micropayments on Mechanical Turk or something like that, you're gonna end up paying a ton of money. So we needed some more efficient way to get lots of triplets labeled. And that brings us to this grid UX. And the idea here is, it's the same thing as what I just showed. You still have an anchor the carrots image on the left here is the anchor. But now instead of just having B and C on the right, we can have a gallery. And in practice, we used one that was 5 by 5. So that would be a total of 25. And then there's a certain amount of forced choice clicking that the user has to do. For illustration purposes, this one had a grid of size 3 by 3, and the users had to click on 4. So we call that a 9 choose 4 grid. And again, it's forced choice. So, but the spirit of it is the same. They're supposed to look at the anchor and then click on the 4 images that they would say would taste more like the anchor than the other ones. So when you do that, you can broadcast that out to a set of triplets. So in one screen, you're kind of tapping into the parallelism of human vision, but they click on those 4, and that gives rise to a set of triplet constraints that you can harvest from that screen. And it turns out you get a lot of data for not a lot of money. So you can get people to label this. And the idea is with that type of triplet-based data, you can build a visual menu. So instead of thinking about food in terms of semantic categories or cuisine types and things like that, you could just produce some kind of low-dimensional embedding that attempts to satisfy those triplet constraints and puts noodles together and savory snacks together and things like that. So how do we do that? So we put together some existing algorithms for dimensionality reduction in a new way. So just as a point of reference, how many people here have heard of TSNE? Okay, so most of you have heard of it. So TSNE is the famous one of the two. It's the pipeline on the bottom. So that's student t-distributed stochastic triplet embedding, a stochastic neighbor embedding. And the goal there, so for example, you could take an off-the-shelf deep learning approach that looks at the images of food. Let's say it's been pre-trained on ImageNet, and you get something like a 1,000-dimensional vector out of it. And instead of doing the one-hot thresholding at the end, you just take the feature vector that this pre-trained network pops out. So that is that backbone's attempt to take in a picture of a food and lift it into some high-dimensional space. And if it's pre-trained on ImageNet, we don't really have a good basis for why that would capture the flavor of food, but it's a baseline. So you can you can produce a high-dimensional signature for a picture of a hamburger or a donut, and that deep learning pipeline is something that's results in high-dimensional data, which can be fed to TSNE and then reduced to something like 2 dimensions to produce something like this. Now, what do we do with the human annotated data? Well, the human annotated data, we pass that through something called student t-distributed stochastic triplet embedding, which is the much lesser known sequel to the TSNE work. So usually when I give a talk, everybody's heard of TSNE, but nobody's heard of TSTE. It was the same authors, it was a very minor workshop, but it's the same idea, but it makes use of triplet-based annotations. Now, as I said, even with the grids, it's hard to get a lot of those. So you're not going to get the same kind of legwork that you would get out of an off-the-shelf deep learning architecture. However, as I've been hinting throughout this talk, even if you harvest 1 million tweets or 1 million pictures of food, it doesn't mean that there are 1 million individual cuisines or 1 million individual viewpoints. Chances are there's a relatively small number of clusters. And so what we do is we take that small percentage of triplet annotations we have, and we create this cost function that combines TSNE and TSTE. And we can control this value of lambda to determine how much the human influence is coming into play. Now, the way to think about that is if the pre-trained network really does capture something about the flavor in the food, then you simply wouldn't need the human expertise pipeline. But think about these kinds of confusions that can happen in food, like guacamole and wasabi. they look really similar, but you don't want to make that mistake and take a chip and dip it in wasabi. A scoop of ice cream, vanilla ice cream, or a scoop of mashed potatoes. They look so similar that professional photographers actually use mashed potatoes in photo shoots. You can't tell the difference, but obviously they taste very different. So when it comes to the human expertise pipeline, there actually are things that human observers can detect in the image, little contextual cues. Things like when wasabi is present, it tends to be in a certain environment, or the little plate that it's on looks different, and so on. So these are all things that in an iterative process, the deep learning pipeline can get smarter. But as you move into more and more domains, inevitably there's a role for those human observers to point out to the deep learning pipeline what it's missing, especially if it's just pre-trained on something like ImageNet. TSTI was originally introduced in the context of music genre inference. So this is a big TSTI embedding for bands. And previously I talked about this motivating example with food images. You're supposed to look at the food, imagine what it tastes like, and then assess the similarity in that space. In this case, the annotators were presented with the names of bands, and it's not like they're supposed to look at the string of the band name and compare them. They're supposed to look at the band, Kid Rock, Limp Bizkit, Linkin Park, imagine what they sound like, and then respond in the same way to the triplet embeddings. And then, just like with the visual menu, instead of having things like music genre, which is a famously difficult thing to define, it's like in the US, we have something called world music. I mean, that's such a bizarre concept. And when I moved to Denmark, music stores, they have a black music section, right? So as you go around the world, the notion of genres is very strange. But the attempt here, what they were attempting to do here is just say, for a given set of observers, how could you produce some kind of embedding that puts similar sounding music together? So what we're starting to do is to use the same type of interface in the context of narratives. And we have a whole bunch of tweets in a bunch of different topics. And they involve things like, well, the hand drying and the paper towels and the air dryers. We have atomic energy versus renewable energy, baby formula versus breast milk, cryptocurrency. There's a bunch of these topics, and we've scraped the data. And we're starting to do these kinds of experiments, these annotation experiments, so that people, instead of just looking at tweets and trying to label them directly, what we're asking them to do is to look at the tweet, think about the world view of the person who wrote it, a little bit like taste inference, and then click on things to assert similarity in an analogous way to before. But this is hard. Like in the case of food, you can fill the screen with up to 6x6 grids, and the human visual system is very parallel and efficient. Narratives are harder. You gotta look at each tweet and you gotta think about what the person's trying to say. You also have to route them to communities that understand those different domains. It's a little bit like like the cuisine for meals. If you show human annotators some cuisine from a region of the world that they've never tried, they're just guessing they're probably gonna do worse than an ImageNet pre-trained ResNet 50 backbone. So again, what we're trying to get at, if we're able to obtain these triplet-based constraints, is something that will allow us to produce these clusterings. And so looking at the results, the way that we set up these experiments is to say, what would off-the-shelf transformer-based architectures do on this kind of data? So any of us can use, you can go to Hugging Face, you can get a T5 sentence transformer, you can go to ChatGPT, you can try to test out chatbots' abilities to infer narratives. But it turns out it's very hard. So if, as a baseline, you take a T5 sentence transformer, which is shown in A, and we're using the same color coding here as what's shown in this hierarchy. So there's actually a continuum of colors here, but you basically have this sort of orangey or purple or blue or green. So the idea is you take the T5 sentence transformer, you take in the different textual content from Twitter, Facebook, etc. You turn it into the high dimensional representation. In the example A, there's no human in the loop at all. And then you just produce just tsne, right? There's no combination with the tsd part. And then we can put the color coding into it to see, did it find any kind of clustering at all, right? So these color codings, these are ground truth. We actually had student volunteers go through and label all those things. So if it got it right, you'd be seeing clumps of purple and clumps of red and stuff like that. It just doesn't know what it's looking at, right? Because why would it? Where is there some repository that OpenAI could have crawled that explains the narratives behind everything that's posted online? Now, some of them are. Some topics, actually, the hand drying one has a decent amount of narrative understanding, but there are a lot of world events that can occur in Gaza or in Ukraine or whatever. And once that happens, the narratives change, and you need to have data hot off the presses to handle it. So as we progress through lots of different off-the-shelf transformer architectures, but what we see down here is what we call SNAC. SNAC stands for Stochastic Neighbor and Crowd Kernel Embedding. That's the one that combines tsne and tsd. So here, you've got that small amount of human feedback in there, and we dialed in lambda at some suitable setting. And it's still kind of a mess. But if you look quantitatively, we can analyze it in terms of triplet agreement level. So we can have some held out data where we know what the triplet responses were in the ground truth. And so we can ask ourselves, when we produce these embeddings, to what extent do they agree with the triplet orderings that human annotators provided? So in this case, the TGR part, you would want it to be 100%. So that would mean that these inferred embeddings are absolute, just completely predicting what human annotators would provide. It turns out we're getting something like 67%. It's still extremely hard, but we are getting some kind of improvement. The kind of, as we inch towards something that could be useful in a newsroom, for reporters, for yourself to try to understand what's happening on social media, the kind of thing we imagine is that for visualization purposes, you'd have some kind of dashboard where when a topic becomes viral, like transgender sports, for example, or transgenderism in sports, every once in a while that term will trend on Twitter. And if you're not up to speed on what's being discussed there, you don't understand what the narratives are. So the idea would be when something goes viral, when it exceeds a certain threshold, you turn on the narrative analysis. You then would collect a huge amount of tweets that are coming in. You use the pre-trained network, like the deep learning pipeline. And then, I'm dreaming here, but the idea would be that the social media companies would then mobilize a certain number of volunteers or paid crowd workers who are knowledgeable in those domains to do the TSD-based triplet labeling. And then you get these embeddings and you can mouse over them and say, okay, like in the case of the paper towels versus the air dryers, you start to see clusters forming and you can mouse over it and see what the individual tweets are saying, right? So get some sense of what narratives are taking shape. Now, the kind of thing that the social media companies have access to that we don't in academia is the forensic data. So they're gonna know the IP addresses where these tweets originated. They're gonna know all of the metadata about the people that are posting these things. But I think these kinds of the forensic data and the this inferred data that we get from Snack, we can put that together to get a very strong hint that maybe a bot campaign is happening. Like a school board election is coming up in some city, and in the weeks before, certain topics go viral because they're trying to smear the opposition. That probably means that there's going to be some huge clusters forming about some scandal. Could be true, could be false, but if you're able to detect that there's a very small number of talking points that are appearing with little perturbations, but they're all resolving to the same narrative, that probably means some funny business is going on. So, as I mentioned, we're in the process of putting together this reference data set that's got 12 different discussion topics in it, like atomic energy, renewable energy, and so forth. And we have this so-called prompt, condition, and generate system that's semi-synthetically producing tweets that are similar to the kinds of tweets that people would write. And the value of these, for those of you who've done any human-in-the-loop annotation, it produces what are called sentinel examples. So the sentinel examples look like organic tweets. If you just show them to an average social media user, they just look like something that might appear in their feed. But we generated it. We know the narrative behind it. So when we put it into an annotation workflow, anytime it gets picked as a similar entity in one of these triplet annotation problems, it's like gold for us because we know that it has some proximity to that narrative. So we're in the process of building these large data sets. And then another thing in terms of visualization, how many people here have seen this periodic table of storytelling? Does this ring a bell? No. So how about TV tropes? Has anyone heard of this? Or maybe one person. So the periodic table of storytelling is built on a site called TV Tropes, which is a crowdsourced site put together by hundreds of thousands of TV and movie viewers who have a massive amount of time. I'm not sure what's motivating them, but they annotate every TV show and movie in terms of tropes that appear on screen. And the tropes are organized into this periodic table. It looks like a periodic table from chemistry, but you zoom in on it and you've got things like Neo, the element, is the chosen one, or DRA is slaying the dragon. What's in place of carbon, the C is conflict, right? So this is partly for fun, but the designer that put this together went to the massive data set that's in TV Tropes and organized it in this convenient way so that if you're a screenwriter, you can think about your screenplay or your story in terms of the tropes that are put together. And so conveniently, they have examples like Star Wars. You can click on Star Wars. It's an instance of something called the hero's journey. And you've got this little molecule. You've got slaying the dragon, the chosen one, you have failed me, the empire, conflict, and five-man band. And that's a tried and true combination of tropes. Now, we also know that execution matters. It's not enough just to have a compelling string of tropes that make a narrative. George Lucas also was extremely successful in how he pulled it off. But you can see Ghostbusters, WALL-E, all of these have these different elements. Now, as I said, this is mainly put together for entertainment purposes. But if we're successful in this moonshot, we're not just going to produce one periodic table of narratives. What we'll do is produce tens of thousands of periodic tables in every fine-grained category you can imagine. So if there's something that's worthy of going viral, and these discussions flare up on social media, like vaccines causing autism, like so many topics that you see get into heated debates, we can produce these periodic tables of XYZ, whatever you want. It's not about what's right or wrong. It's just about organizing it. And one way to think about the benefit of the organization is that the people who do have time to do fact checking can't handle the fire hose of millions and millions of tweets being thrown their way. So there's considerable value that you would get by being able to cluster the millions and millions of entities into smaller piles of things, in this case tropes, that the fact checkers could analyze in their sweet time and then propagate to the other content that's tapping into those tropes. Now, we're not even close to doing this yet, but we want to think about compelling visualizations that will allow non-experts to understand what we're doing. So if someone's joining a news agency as a reporter and they're about to start their first foray into writing articles, they're about to step into the world of tropes and they don't necessarily know that. So we want to produce these mechanisms that can help in understanding that. I think I will stop here just to reiterate, we are just at the beginning of this project, putting together some data sets, getting to know people that are in adjacent areas to AI and machine learning, curating different debate topics and learning new ways of getting data annotated, but it's a very challenging area, and you're witnessing it right at the beginning. We might fail completely, but if you get the chance to start a national AI research center, you might as well try something kind of crazy. So I'll just stop there, and thank you for your attention.